So on page 431, we are going to highlight this formula. And what this formula allows you to do is find the future value of something when a series of equal investments are made at equal time intervals. And the compounding period is the same. This becomes this formula. So in other words, you want to save some money. You're planning on going on a trip after you graduate. That's 18 months from now. And so you're planning on saving some money. So you decide, I'm going to put away $50 or $100 a month from now until then at an interest rate of such and such. How much money will I have after that? Well, this formula allows you to figure that out. Again, you would get the formula and all of this information, where R dollars is the regular investment, I is the interest rate per compounding period. So in other words, I is equal to the interest rate divided by the number of compounding periods. So that one's a little bit complicated. And N is the number of investments. So when we get to example one is going to use this formula. We're going to solve it algebraically, and then I'm going to show you a program that's built into your graphing calculator that you can use to check to see if your answer is correct. So again, we're going to start by writing out the future value formula. Future value equals R 1 plus I to the n minus 1 over I. And I've got to add the correct brackets in here. How many monthly investments, so we're going to be solving for n, of 200 would have to be made into account that pays 6% annual interest, compounded monthly, for the future value to be $100,000. So we start by plugging in everything that we know. We know the future value. We want $100,000. We're putting away $200 per month. Interest rate here, this I is interest rate per compounding period. So the interest rate is 6%, 0.06, divided by 12, because that's how much it would be per compounding period, to the exponent of n minus 1 all over 0.06 divided by 12. So we want to solve for n in the exponent. We've got a bunch of extra stuff. So just like we've done in the past, try to simplify this first. See if you can get the power all by itself before you take the log of both sides. So I'm going to start by multiplying both sides by 0.06 over 12. Go to my calculator. If I had $100,000 multiplied by 0.06 divided by 12, it becomes 500. That gets rid of the fraction. What would you do next to simplify this? Divide by 200. Excellent. Dividing both sides by 200, can you see that that would become 5 over 2? Are you okay if I just simplify that to 2.5? And once I divide by 200, can you see that I no longer need those square brackets? That I could just have 1 plus 0.06 divided by 12 to the n minus 1. What's the last thing I would do to simplify this to get my power by itself? Add 1 to both sides. And now we can take the log or natural log of both sides. So log of 3.5 equals, the n would come out in front, log of 1 plus 0.06 divided by 12. N is equal to log of 3.5 divided by log of 1 plus 0.06 divided by 12. Go to our calculator, type that in. So yes, there is more simplifying that needs to be done at the beginning, but the idea stays the same. And according to this, we would need to put in 251 payments, 251.1. 0.2, thank you. 251.2. And this would be one of those situations where to get $100,000, 251 payments wouldn't be quite enough. So often you extend it and say, round it up to the nearest whole number. You would need 252 payments. If you divide that by 12, because you're making monthly payments, so if I take this answer and divide it by 12, just about 21 years. So if you started now, 21 years, you'll be 36? That's not bad. Okay. At 36, then all of a sudden you go to that account and you have 100 grand in that account. I kind of wish I would have started that. I would like to have an account right now that I go, ooh. There'd be.
Is there even banks that do 6%?
It's hard to find banks that do 6% interest in North America. At the top of your page, I want you to write Tvm Solver and write out the following. First of all, you can find Tvm Solver by turning on your calculator, pushing apps, clicking enter on finance, and then enter again, the very first one. And the following screen comes up with an N, an I. I'll show you again, don't worry. PV, PMT, FV, C, P/Y, C/Y. So if you go to your calculator, hit the apps button, apps button, then finance, then number 1, Tvm Solver, this screen comes up. Now, what we need to do is label what each of these things mean. And this is what you're going to put in your notes. N is your number of payments. Interest rate, not a decimal. Just if it's 7%, you just put in 7. PV stands for the present value. Any guesses what FV stands for? The future value. Payment stands for payment. P/Y is your payments per year. And C/Y is your compounding periods per year. So in the question that we just did, N, I, PV, PMT, FV, payments per year, compounds per year. We're going to get the calculator to solve for the number of payments. So some of the things that we can plug in from this question. In this question, we knew the interest rate was 6%. So we can put a 6 in for interest rate. The present value is 0. Oh, and we have to make a note. Okay, there's a special note I want you to add. Anytime you are receiving money or things, the value is positive. Anytime you are paying or, I'll say, investing, taking money out of your pocket and putting it somewhere else, the value is negative. So the calculator needs to know, are you getting money or are you putting money away? So for here, our present value, we have no money in that account, but we are going to be putting away payments of $200 a month. So because that money is coming out of our pocket into the bank, we'll enter that in as negative 200. The future value will be positive $100,000 because we'll take that money and put it back into our pockets. Don't actually recommend trying to put $100,000 into your pockets all at once, but that idea. So now that value is positive because you're getting it back. You are making 12 payments per year, and it's being compounded monthly, so that's 12 per year as well. If this was a quiz and you were using this to show your work, I like to put a star beside the one that I'm solving for with an arrow so that it becomes clear that everything else is what I entered in, and I want to solve for the number of payments. I just put a star there saying this I'm solving. No, I'll show you what you do. So we'll leave n right now. The interest rate was 6. Present value is 0. We're putting away $200 a month. Future value is $100,000. Payments per year are 12. And 12. Alpha, solve. And that is exactly the same number that we got, 251.17. It's exactly the same number that we got from solving with the equation. Just a lot faster, right? So to solve, yes. So if you've missed how I did the solve button is above your enter button. Okay? You have to push alpha and then solve. So the question is, you're saying, well, I'm making a lot of money right now. I could even put more than $200 a month away. So the nice thing about this program is you can play around with things without having things take a long time to calculate. Let's say you put away $400 a month. How long is it going to take you to get $100,000? Alpha solve. Now it's 162 months. You can even do math in here. If you like say, I want to know how many years that is, divide by 12. You can just even do calculations within this. Oh, 13.5 years. If I want $100,000 in 13.5 years, I just need to put $400 a month away. If you can change certain things, maybe you want more money. How long is it going to take me to become a millionaire. I can put $400 away a month. Will I become a millionaire? Alpha solve. 521 payments.
How would you solve for years again, sorry?
So I did just divide that answer by 12. Yeah, 43 years. You want to become a millionaire in 43 years? Start putting away $40 a month, $400 a month now.
I don't have $400.
I know. That's the hard part. Usually you don't have $400 a month right now.
But honestly, that's actually kind of good because if you did have $400 a month, I'd only be like 50
Right.
when I took it out, and then that's like
Now, so
I'd have to put my entire future.
let's go back to the original question, which was $200. Okay, alpha solve. This should be 251. No, what am I done wrong? Oh, it's still $1 million. Yes, thank you. There we go. $100,000. Okay, 251 payments at 6%. Okay, unfortunately 6% is hard to find right now. You might be able to find 3%, which is still really good, but you might be able to find an investment that locks away for 3% right now. How much longer does it take? 324 payments now instead of 251. So quite a bit longer.
Hey, if I put in $100 a month at 3%, it would only take me 41 years to become $100,000.
Yes.
How many years?
41. So I'd be 56.
I like the word 100,000 air.
Thank you. It's more realistic.
Excellent. Excellent. Okay, let's look at, the questions you can do for the example 1 are 3 and 6. We're going to do example 2 right away.